So because with the 3 white houses, if in this problem we actually just had 3 white houses and let's say 5 places where we could put the houses in this order, first, second, third, fourth, and fifth house in a row, so that like we have water here and maybe trees here or something. If we just have white houses, so let's say we have 3 white houses, so we could put them as to occupy any single group of 3 house spots. And here, like with these 3 white houses, we can just realize that it's not going to matter where you place these houses, just on the real life level, because you're not going to be able to say, well, this house is now closer to this spot, because there's no specific houses, they're just all the same in terms of color and maybe everything about them. Since we can't figure out right away how many different house spots these 3 houses could take up, which would be finding how many groups of 3 there are in 5, instead we can realize that in order to find the total number of orders of 3 items in 5 items, we can do a simple solution to that. Just 5 times 4 times 3 gives us all possible orders of 3 items picked from 5 items. And because we know this total intuitively has to equal the number of groups of 3 times the number of arrangements possible of any group of 3, we can then say, okay, well, we know the number of arrangements possible of any group of 3. That's just 3 factorial. 3 times 2 times 1. And then we can solve for how many groups of 3 there are in 5. This is in 5 items. Groups of 3 items and 5 items. So,